Is this the next cosmic threat after Oumuamua? Comet 3IATLAS is on a journey that's about to get incredibly dramatic. We're talking about an icy visitor making a deep dive into the inner solar system. But what does this mean for Mars, and how has NASA reacted to this? The comet is on a spectacle-filled trajectory before it's temporarily swallowed by the sun's glare, and it has two major milestones coming up. First, it's making a close-quarters pass by the planet Mars. More dramatically, on its approach to the sun, the comet will cross the threshold of the inner solar system. It will actually penetrate inside the orbit of Mars, reaching a point between the red planet and our star during this part of its journey. But that's not even the closest it's gonna get. As 3IATLAS gets close to Mars, a huge question comes up. Are we looking at a potential collision? And will this strange rock from deep space ever pose a direct threat to Earth? Right now, the chances of an impact are incredibly low, but the question of where it came from is far more interesting. Most comets we track belong to our solar system. They orbit the sun just like the planets do. But 3IATLAS is a bit different. It's an interstellar visitor. This means it didn't originate here. Instead, this comet came from deep space, and it's making a one-time pass through our neighborhood. The initial observations of this interstellar traveler were reported to the Minor Planet Center on July 1, 2025 by the NASA-funded Atlas Survey telescope located in Rio Helado, Chile. But that wasn't the whole story. After the discovery, scientists dove into the archives and found earlier pre-discovery sightings from 3 Atlas telescopes and Caltech's Zwicky Transient Facility. These records track the comet back to June 14, 2025. Since its official discovery, the world's most powerful eyes have been turned toward the comet. We're talking about massive instruments on Earth, like the Very Large Telescope and Gemini North, and of course our space-based powerhouses. Both the Hubble Space Telescope and the incredible infrared vision of the Webb Space Telescope have been capturing images of 3IATLAS, providing us with invaluable data on this unique visitor. These telescopes are so powerful, it's like spotting a bumblebee at the distance of the moon. But what exactly did these powerful instruments uncover? By putting all this data together, scientists have been able to pinpoint the essential details about the comet. We now have a clear picture of its physical characteristics, including the size and shape and what it's actually made of. Crucially, researchers have confirmed the presence of CO2 and water ice within the comet. But perhaps the most exciting finding is the strong evidence suggesting that 3IATLAS may be the oldest comet ever observed by humanity. All these observations, combined with powerful computing, allowed astronomers to precisely calculate the unique orbit of 3IATLAS, giving us a remarkably accurate prediction of its exact path through our solar system. Its orbital path maps out a true grand tour of our solar system. Diagrams released by NASA show the comet passing near several major planets: Mars, Jupiter, and even Earth. Scientists calculate that the closest 3IATLAS will get to our planet is roughly 170 million miles away. Believe it or not, that's even closer than some near-Earth asteroids we've tracked in the past. To use astronomical language, that distance is about 1.8 astronomical units. Remember that 1 AU is the average distance between the Earth and the Sun. Considering this comet originated in deep interstellar space and could have been flung anywhere in the universe, coming within 1.8 AU of Earth is kind of a stunning celestial event. But when does this highly anticipated event actually happen? According to the US National Science Foundation's NORLAB, the comet's closest approach to Earth is due on December 19, 2025. So make sure you mark that date. It could be a once-in-a-lifetime event. Now, before that, another dramatic part of its journey occurs around October 30th. This is when 3IATLAS gets to within 210 million kilometers of the Sun. Would you go to Mars if you had the chance? Let us know in the comments. Okay, at that extreme point, deep inside the orbit of Mars, this interstellar visitor will be absolutely rocketing through space, traveling at an incredible speed of 25,000 kilometers per hour. But even before the comet makes its dash toward the Sun, it has a crucial encounter with the red planet. 3IATLAS will make its closest approach to Mars on October 3, 2025, reaching about 18 million miles. Now, that's roughly 0.19 AU, or about 1/5 of the Earth-Sun distance. Now, this has led to the ultimate question: is this thing going to smash into any of our planets? The answer is no, and here's how we know. Modern astronomers are able to pinpoint the orbit of objects like this with remarkable accuracy. By continuously observing tracking motion and gravitational effects, scientists can precisely predict its future path, confirming that all 3 planets are going to be safe from impact. Think back to the near-miss events that we've covered before. For instance, you might remember asteroid 2024 YR4, which made headlines because of the very small chance it might have impacted Earth or the Moon. What happened after that? Every passing day, astronomers were able to refine that object's orbit. The tiny chance of a collision rapidly disappeared, all thanks to constant observation. We're starting to see the same scientific certainty with this comet. All of the precise evidence and orbital calculations strongly point to Comet 3I/ATLAS safely passing through our solar system without posing a threat to any of the planets, including our own. In fact, there's already discussion among scientists about Mars missions taking part. Spacecraft like the European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter are perfectly positioned to carry out observations and perhaps snap a unique image of this interstellar visitor as it speeds through our neighborhood. Another key instrument that could join the hunt is the powerful high-rise camera on board NASA's Mars Reconnaissance Orbiter. This camera is capable of imaging Comet 3I/ATLAS at an impressive resolution of 30 kilometers per pixel. This resulting close-up image could be vital for science. It would allow astronomers to separate the 2 main light sources, the small icy nucleus of the comet and the large fuzzy surrounding dust cloud. This helps us measure the comet's activity with greater accuracy. But that's not all. HiRISE might also use its superior resolution to scan the space ahead of the comet. Why? Scientists are looking for any smaller precursor objects that might be traveling in front of 3I/ATLAS. Near-Earth telescopes simply can't detect these smaller fragments, but HiRISE, positioned so close to Mars, has the best chance of spotting them. The potential for data collection doesn't stop in Mars. A paper submitted by Cornell University suggests an even wider opportunity for observation. It proposes that other distant spacecraft, including NASA's Europa Clipper, the European Space Agency's Hera mission, and even the distant Lucy spacecraft may actually pass through 3I/ATLAS's cometary tail. Just imagine that opportunity. These missions could potentially directly sample and analyze the conditions and composition of the interstellar visitor's tail. It seems clear that our best, most insightful views of 3I/ATLAS and our greatest chances for gathering critical data on this unique visitor may not come from telescopes here on Earth, but instead from the dedicated spacecraft we've already launched to explore other planets and deeper regions of our solar system. One mission is uniquely positioned to capture the comet at its most dramatic: the European Space Agency's Jupiter Icy Moons Explorer, or JUICE. Between November 2nd and 25th, JUICE will pivot its instruments toward 3I/ATLAS. These crucial observations begin just after the comet hits its perihelion, its closest approach to the Sun. That moment is critical because the Sun's intense heat drives the comet into its most active phase, causing its ices to rapidly vaporize and stream out into space. While missions around Mars, like the Mars Reconnaissance Orbiter, the Tianwen-1, and HOPE, have a great vantage point and excellent equipment, the data collected by JUICE during that perihelion period is likely to be the most vital for understanding this interstellar visitor.